All right, for your geometry work sample, you're going to be working with coordinate geometry, which means you're going to need the coordinate plane and also your understanding of quadrilaterals. Understanding. For your coordinate plane, there's going to be two pieces that you need, and those are both going to be on your high school formula worksheet. And if you look down here at the bottom, you're going to want to use the distance formula and also the slope formula. All right. Oops, sorry. So those are both down there at the bottom. And those are the only two that you're going to be using for this problem. Remember that quadrilaterals can be a parallelogram, or you have opposite sides are parallel, and congruent. A rectangle is a special parallelogram, but with 4 right angles, as is a square, and a square is special because all 4 sides are congruent. Okay? All right, so on your coordinate plane geometry, you're going to be given coordinates to use. And a coordinate, remember, is an ordered pair where we have an x value and we have a y value. Okay? So for your quadrilateral, you're probably going to have 4 vertices, okay? And the 4 vertices are just the 4 points. So, you know, we could have this and okay. So if I went to graph this, I could graph it, or I could use those 2 formulas that we had. So the one thing I'm going to need to do is I need to know, do I have parallel lines? And you'll remember that parallel lines have the same slope, right? Same slope, and they never cross. So to use, I'm going to use the slope formula, which is right down here, for my points. Okay? So let's find the slope between -5, 2 and -1, 7. Okay, so this is where I use my, I've got to make one of these 0.1 and one of these 0.2. All right. 0.2, remember I've got my x and my y. So it's y2 minus y1. So it's going to be -7 minus 2 over x2 minus x1. Remember, this is my second point, so -1 minus -5. It's really important here that you remember your integers and that when you're subtracting a negative, it's really like adding. So my slope between these 2 points is -9 over 4. Okay? Slope can absolutely be in a fraction because it is a ratio. It's the rise over run. So having it as a fraction is actually the best way to leave it. Okay? So we could find the slope of a second line. We could find the slope between these 2 lines. Again, y2 minus y1. It doesn't matter which is 1 or 2 as long as I make sure I'm not confusing these. And this is going to be hard because I have 7 and 1 for both, but one's negative and one's positive. So if I did -7 minus 7 over -1 minus 1, and this would give me a slope of -14 over -2, which is equal to 7 over 1, or 7. So far I do not have parallel lines, okay, but I need to keep going. Parallel lines will help me to see if I have a parallelogram. If I have opposite sides that are parallel, if I have one pair, then I have a trapezoid. Okay. Now, there's a special kind of trapezoid, so I would need to use the distance formula to see if I have congruent sides, because there is a trapezoid called the Isosceles Trapezoid when the two sides are congruent and these sides are parallel. Or it could be a regular trapezoid where I don't have those congruent. So the distance formula is needed to find the length of each of the sides. Okay. If I did have parallel lines, what's to keep me from knowing, how can I tell if I have either a square or a rectangle? And so that's where this slope is still really important, because we need to know, are there any right angles? Okay, and the right angles are really important because that's going to tell us if we've got a square or a rectangle. And to determine if we have right angles, we look at the slopes. And the slopes are going to be perpendicular, opposite reciprocals to be perpendicular. So that means that if I have a slope of 3/2, my slope that's perpendicular to this has to be -2/3. Okay, so do you see how it goes from being positive to being negative, and it goes from being 3/2 to 2/3. So a line that is perpendicular to a line that has a slope of 1/3, the perpendicular line would be -3/1. Okay? If I had a line that was -2/5, my line perpendicular to that would have to be a positive 5/2. Does that make sense? So this is our opposite reciprocals. I think it's an O, reciprocal. Okay? All right. So I should find my slopes, figure out if I've got any parallel lines. That'll help me decide if I've got a parallelogram or a trapezoid, and then look at opposite reciprocals to see if I have any right angles. Okay? The next thing I'm going to do is find the distance between these. And I'm going to have to use the distance formula for this. So let's take a couple more of those points. I'll just bring them on over. We had -5, 2, and -1, -7. All right, so the distance formula is right up here. And what we're doing is really Pythagorean's theorem. And we're taking the change in x and squaring it, adding it to the change in y, squaring that, and then taking the square root. Okay? So my distance formula, again though, I just need to take my x's and y's and plug them in. So it's x2 minus x1, squaring that, adding y2 minus y1, squaring that. Okay, so again, if this is my first point and this is my second point, my x2 is going to be right here. So I've got the distance equals the square root of -1 minus, and then x1, which is -5, so -5, parenthesis, square, plus y2, -7, minus y1 is 2, parenthesis square, okay? And the reason this formula is the way it is because when we square something, we're going to get rid of the negatives, and it'll be a positive, and then when we take the square root, we're undoing that square, but this is ensuring that we have positive numbers, because you can't take the square root of a negative number. So again, remembering integers, when I'm subtracting a negative, I'm really adding, so I've got the -1 plus 5, which is 4, and I'm going to square that and add that to -7 minus 2 is 9, and I'm going to have to square my 9. So this is really going to be, the distance is 16 plus 81, which is the square root of 97. For this problem, we could just leave it as the square root of 97, or you could put it in your calculator and round. However, if we're talking about needing congruent sides, remember congruent means exactly the same size, exactly the same shape. So even if I was to round, and say at some point you got like 6.87, and then you had another square root, and you had, 6.9, those are not congruent, okay? They would round to be about the same, but there's a difference there, so those would not be congruent. So if you kept it here as a square root of 97, then you know if you have another distance that's the square root of 95, even though those would be close, they're not congruent, okay? So that's something to keep in mind. You're just looking for if it's the same, so there's no need to go any further than this, because this will give you the actual amount, the very exact amount, okay? So you would use the distance formula. The reason why the distance formula is important is because if I have 4 congruent sides, I could have a rhombus, or I could have a square. The difference, of course, is that a square has 4 90-degree angles and a rhombus does not. If I have, there's also a kite is a special quadrilateral, and a kite has 2 pairs of adjacent sides that are congruent, so that would be important to have. And then also rectangles have opposite sides are congruent, and right angles, right? So these would have to be congruent, and then the other side would have to be congruent, along with having those right angles. And we'd need, again, for the right angles, we would need the opposite reciprocals. Squares, all of these sides are congruent, and they all have 4 right angles. Some other characteristics are parallelograms. We have diagonals that are congruent. So, especially for our work sample that we're doing, if you wanted to prove it a second way, parallelograms all have diagonals that are congruent. And let's see. We were talking about kites. our kites are going to intersect at a 90-degree angle. And for trapezoids, if it's an isosceles trapezoid, it's going to have a diagonal that's congruent, but otherwise it would have a mid-segment that's parallel to the other two, but that's going a little above and beyond. So rhombus, square, rectangles, and parallelograms will all have diagonals that are congruent. A kite will have two pairs of adjacents. That means they're touching, right? Those two are congruent and these two are congruent. And then the diagonals intersect at a 90-degree angle. And those are really the specialties for having any quadrilaterals and why you would want to use the distance formula, the slope formula, and classify the quadrilateral.